Thank you, Anish. Good evening, everyone. I'm Cornel. I'm a senior software engineer at Roku. And I'd like to talk to you about React rendering performance this evening. But before I get into it, let me just tell you a couple of things what to do with our team. And then we're going to go with a deep dive into performance. So the customer care team supports more than 71 million customers. We have over 20 countries to support, and also more than 1,100 device models. That's like different kind of devices. In total, those are 107 million devices that we need to provide support for. This means that our customers might want help with setup, or maybe they have some issues, and we'd like to provide them with up-to-date accessible support. Now, there are a couple of channels we can provide this support for them. The traditional one over phone, chat, email. We also have the Roku community site, the Roku blog, and the main Roku support site where anybody can find answers to their questions. Most of this content is web-based. We have FAQs, self-service applications, and contact us pages. And this web content is made by a CMS application. And that CMS app will be the main character of our case study. Now, this CMS editor can be used by a lot of different kind of people, not just developers. So writers, marketing team, support team, actually could be anyone who's producing content. And well, this content can get out of hand. Hopefully it doesn't, but yeah, we need to prepare for the unexpected. There could be lots of components on a page. And yes, it can become really slow. Every single key press might take ages. Drop-down menus might be not that reactive. They become sluggish. You have to wait even when you add a new section to that page. And as the content grows, the entire system will get slower and slower. Now, let's try to think of what can go wrong, why this is so slow. There could be a lot of reasons to this. Bundle size, we might have forgotten to split our bundle, or we could have lots of API calls that take ages. We might download lots of content. But for this presentation, I think let's look at the re-renderings part of these performance problems. Probably we're going to see some unnecessary re-renderings. Before we get into the actual investigation, let's just remind ourselves why exactly React does rendering. Now, rendering is the main action of creating the HTML that the browser will eventually display to our customers. And there are 4 main scenarios that this happens. The first one is when we bootstrap the application. This is the first render. All the components needs to be displayed on the screen. And then the other base scenario is when only one of the components update the state, and they just want to display the new data. Now, we have re-renders as well. And those re-renders can happen when the parent changed something and it needs to re-render the children. The other situation is when we have a context update. The context update similarly will trigger a change on all the children. And I try to highlight with yellow the components that do rendering in this case. And like you see, basically, it has like a waterfall effect. All the components on that branch will do re-rendering in these scenarios. This will come really important because our performance will depend on how many calculations we do, and the more renders we have, the more calculations going to happen on the components. Okay, let's investigate what happened in that application. Probably, I'm not giving away a big secret that I used React developer tools to figure out what's going on. There are two key functions I like to use. One of them is the highlight of the updates. If you turn that on, you can see on the components if they do the rendering. So you just type away, you click around, and all the components that do rendering is going to have like yellow outline. And the profiler will give you a flame graph of the rendering that happens, and it's going to tell you how long that render took. And it's going to also tell you why that render happened. So it's going to say if it was a parent re-render or maybe a state change. Moving on to our CMS editor, what we need to notice from this flame graph is a couple of things. All the input events that happened were causing a context change. Now, this context was used globally on the page. And as every input event changed the context change also triggered a re-render on the children. And actually, that's visible from the frame graph there that the parent component just made everything re-render. The child components also have their own calculations. So every single one of them will do like another small bit of work. And all of this will add up into a lot of CPU time and calculations. Even the components that are not visible will do re-rendering, and that's not really useful. I mean, we are not even seeing them. So that must be an easy fix, right? We just wrap everything in React Memo and we are done. Well, I have some bad news. Use Memo is not effective with use context. So what else? Let's see what we have here. Partial updates. Yeah, if we update only one part of the context, that's not going to fix our issue either because the entire context object is being updated. And that still triggers the re-render of the whole page. Well, there is too much code to rewrite as well. That makes our lives harder. So yeah, we are doomed, right? We should just throw the entire application out the window and npx create React App version 800. Or we could go with the other option and just try to refactor the thing. So how to fix this? There are a couple of options we could go with. First one is to split the context into smaller pieces. What this means is create more smaller contexts and just create one context for one part of the application and another one for the other. We could also replace the context with different implementations like Watchable Dev that Kevin presented previously. It's a good example for filtering those context changes into just partial and do updates only when the interesting part of the state has been updated. We could also keep references between renders with useref. This could help us save the time that on every render we do by creating a new event listener. When we have no context interference, we do not have a higher level context, the use memo will become more effective. And we can use that to stop the render propagation down the component tree. We could also fix our hook dependencies. I saw in lots of projects, people use code linting solutions. And what they do is just stuff in every single dependency in the hook, which will cause that hook to actually calculate on every render. And I think it's better to tell React what we want to render. Another strategy could be to use selective rendering. There are a bunch of third-party libraries there with React, where you can even use a React window and just render the things that you see on the screen. Or there are other libraries for select dropdowns where this is already integrated in that and will not render the things that you don't see. Okay, now that we fixed our applications, let's try to keep it that way. There are some things that we should keep in our heads to make sure that this performance issue won't pop up in the future. First of all, let's use the React APIs consciously. So there are different kind of hooks in React for a reason, and they're going to do their job on different conditions. And that's a really great way of controlling the render cycles and to not render what we don't want. Using these APIs consciously is actually telling React how to render and what to render. Also, it's good to think about our component in the component tree. Let's zoom out and understand where we do need to do those calculations. Probably filtering 1,000 elements is not the right place to do in like a long list for every single list element. The other strategy we could have is to use selective rendering to only render what we really need to render. If we change a piece of data that's probably linked to just one input field or one div, we don't want to re-render the whole page because we changed one single div. Only render what's necessary and stop the render propagation. Render propagation is one of the major contributors to the performance issues. Basically, you just render the whole up and cause you a lot of problem. Thank you very much.
Thank you. We're running a bit behind time, but we might have time for quick questions. No one asked. Maybe it's time to use Svelte. No one got that. Okay. Anyway, any questions from anyone?
Hello. So where does server-side rendering come into play with all of the strategies that you've just
That's a really good question.
about?
Yeah. That's a really good question. So server-side rendering comes into play before these render hooks. It's on the server, the initial render will basically create an HTML, and that HTML then it's being used by React later on to do all these kinds of rendering. So server-side rendering can help you a lot when you're trying to optimize for SEO or for loading speeds, because your initial contentful render will happen much earlier as you already get the rendered HTML from the server. With React rendering performance, it's more around the interactivity of the application. So server-side rendering can't really help you fix things when you're typing something, and that's why it's slow. Does that answer your question?
I think it can help in a lot of cases, though, can't it? Just to get some of that initial page load sorted. But if your problem, like you say, if your problem's not because of the initial load, the problem's because the interactivity, you're still going to have the problem.
Yeah.
Which is trying to re-render too often. Yeah.
Yeah, I didn't have enough time to talk about all the kinds of
no,
but so much issues like I mentioned earlier. Yeah.
But great advice though. Will you be publishing your slides? Because I'm sure one or two people might want to look at them.
Sure.
It's actually a problem that you see quite a lot in the wild. So yeah, good advice. Thank you very much.
Thank you. I think I'm going to hand over to Felipe.